name is Noah, this is Jordan, Nathan, Yara, and today we are presenting our manual and automatic XY multicolor pen plotter. So for the mechanical chassis, we have an assembly of 5 aluminum bars with a belt-driven plotter. There's 2 stepper motors mirrored across the Z-axis to minimize the sway of the pen. The gantry bar is connected with 3 wheels on each end to hold it stable and allow for movement along the axis. And this gives us one-dimensional movement. And then for the other dimension, we have a motor on the back end of the pen plotter itself, the pen tool head, which allows it to go across on the Z-axis.
Great. Now let's magnify into the system onto the actual plotter head itself. This plotter head consists of 3 motors, one EMA motor attached to the back, as well as a servo motor to select the color, and another servo motor to lift the pen up and down onto the page. Essentially how it works is you have an angled revolving disc of however many pens you like, and or the color options, and then that would be calibrated in servo with the Arduino code, just to sort of gauge at which values correspond to which colors, essentially. And then this is all mounted to the gantry, same way the gantry, like the Y gantry, the X gantry is mounted to the actual frame of the pen block.
As far as our software goes, there were 2 main parts, being the automatic system and the manual system. Our entire system was controlled using an Arduino Mega, and to get images to convert into G-code, we used a combination of Inkscape and Durable Plotter. Inkscape was used to translate the images into SVG files, and then the Durable Plotter was used to translate those SVGs into G-code files. For G-code reading and motion, we used 2 limit switches, which may be a bit difficult for you all to see from over there, but this was used to home in on the origin point. For our G-code, we ended up reading it by saving it into a header file. This ended up putting some limitations on our system. We were able to use approximately 100 lines of G-code in a header file before it started interfering with the rest of the system's functions. The code we ended up using for the automatic is partially created by us and partially a result of ChatGPT.
So, like I said, we encountered some problems with incorporating both codes together. So we did manual and automatic code separately. So for the manual code, we had joystick control. So we used the joystick to control XY movement using the analog to map the analog input to the stepper motor speed, so we could control speed. And we also incorporated dead zone into it. And then for the color switching and the pen raising, each position was assigned a number on the keypad, so we could switch between the 5 colors by pressing the number on the keypad. And then to raise or lower the joystick, we use the joystick button, and we could click the button to raise or lower, and we just debounce to make sure we didn't have multiple instances. And then we try to use free RTOS library, and it worked well for when we had the code separately, but we encountered some limitations, and when we use the header file, the Arduino started to slow down and stuff, so we had to separate it. So that was our final solution, to separate code.
In terms of the requirements we set out at the start of the course, we had 3 functional requirements, those being to be able to draw within 1.5 millimeter tolerance of whatever the inputted motion or image is. This was to keep good accuracy. The second was being able to switch between more than 4 colors, and the third was being able to change from automatic to manual control. In terms of accuracy, we were able to bring it down to approximately 1 millimeter tolerance, as you may be able to see in the picture in the top right corner. We have 5 available colors, and there are more slots to to add more colors if so fit, if so deemed, up to around 7 or 8. And originally, as Yara mentioned, we wanted to have the codes, the automatic manual all be one code, but unfortunately we did have to split it up into 2 separate codes, but they do both exist. In terms of our real-time constraints, starting with our hard real-time at the bottom there, we wanted the joystick input to be read and carried out within 40 milliseconds of the input being received. And after measuring some timestamps before and after, we ended up getting an average of approximately 0.8 milliseconds. As for the stepper motors, we wanted them to respond within 40 milliseconds of each other, and we found that they ended up responding within 0.5 milliseconds of each other. In terms of soft real-time constraints, the pen should be able to lift within 40 milliseconds after a lifting command is issued. For manual mode, more than 90% of the time. We found this to be the case around 95–98% of the time, and is able to do it within 3 milliseconds. And the final soft time constraint is a very similar thing. The pen should be able to lift within 400 milliseconds for automatic control. And because the manual system has more things to consider than the automatic system, and the manual system was able to succeed quite well, therefore our automatic system also succeeds in this.
All right, so now we're going to present a live demo of either the manual or automatic mode action. So what we can do since great. Boom. Yes. Since you can't really like see the intricacies of the plotter, we're going to just live stream it over here on the big screen. Hello Nathan, how are you doing?
Oh, I'm excellent, thank you for asking.
Alright, so you can share your video.
Of course. Oh, this is the wrong way. Seriously.
Perfect. Alright then, see this bad boy in action. So as previously mentioned, you have the entire frame over here, specifically y-axis bar, or gantry that moves. And then the print tab as well, that moves along the z-axis. So anyways, let's get a automatic demonstration, or let's do a manual first.
Select color.
Yeah. So so pink. Very good.
Just like up to the colors. Click to lower. Yeah.
Great. Yeah. Try that. All right. So as Noah also previously mentioned, there are limit switches here to calibrate its ones and zeros. So press of button on the keypad, it will automatically adjust. And it'll be ready for automatic. You should press this. Yeah. All right, so if I were to zoom this a little bit over, you can see that what we tried to have it create was just a square as well as a semicircle as well. In between lines of G code, yes. We wanted to
37.
great, thank you. Let's start this up.
20 more seconds.
That's it for the presentation. 20 more seconds.
No, that's it. Okay.
Yeah.
All right.
Fantastic. Okay.
We do have a few limitations we would like to talk about right at the end though.
Sure.
So as we talked about, we came across a few limitations with the project. So one of them was that the stepper speed seemed to slow down a lot as the code base got larger. And the goal is to hopefully carry this project forward over winter break and try to improve it even further as just a personal project at that point, and try to work through some of the bugs in the program, as well as work on improving things like the part quality and overhauling potentially how the G code is processed, swapping from a header file to a serial. And hopefully with all that, we can do more complex shapes, like perhaps Miku.
And I'll expand it over.
And now that's the end.
Okay. Thank you. Questions? From the audience? Are those that promotional sale?
No, they're ripped off an Ender 2 Pro.
Okay, nice. No, this one here, I think I was looking at it, it looked kind of similar to what I picked up.
They're just standard NEMA 17s.
Yeah.
So, yeah.
Okay, any questions? No. Alright.
There is one question.
Sorry, so all the pink stuff is ever 3D printed?
The pink and the blue, they're just done with separate PLA on different printers.
Okay. And then the aluminum was,
Aluminum was purchased off Amazon and then cut in my garage.
Oh, so you use a CNC shoot?
Yeah.
Okay. I have some. So you're saying it was causing problems when it got more than 100 lines. Is that strictly just because you ran out of memory?
Yes.
So you're putting like the entire G code in the ROM
Yeah.
and do it?
That's the
Essentially,
for a
for-
header file.
Oh. Did you consider like, what if you just stream the G code over USB serial?
Yeah, absolutely.
Yeah, that was the immediate first thing that we realized once we ran out of space. We didn't have time to implement that.
Yeah, we did actually find some sort of like plan of action for that. We would first have link some sort of communication between Arduino and a Python script that housed all of the lines of G code on Python script. But then, upon request of the Arduino, output a line of G code to the serial monitor, and then the Arduino would read it. Though that would absolutely slow things, slow the processes down because there's a lot of like information processing there, a lot of things happen.
Okay. I saw you did some timing analysis on your stuff. You had some numbers there. I was wondering how you calculated those numbers, how you measured those timing.
Mainly we did it by just adding timestamps into the system. Usually we just put like originally we did with milli, but
Some of them were just too fast. We had to go to nanoseconds, is it?
micro.
Micro.
We went down to micro to get more accurate readings because sometimes it would read 1 or 0, and we were looking at it and like either that's too fast or like not. So shrunk it down. But basically, we ended up for most of the constraints just taking the time under the assumption that like a previous similar input was put. That's when the start stamp was, and then the end stamp was once that same action was redone.
Okay. Any other questions? Yeah, the new pen design isn't what was originally promised, but I would say it's quite innovative. So, nice.